Hello everyone and welcome to the next part of 8086 microprocessor, which is the interfacing of 8086. So first of all we have to know what is called interfacing. The definition of interfacing means it is the process of connecting and managing communication between a computer's central processing unit, that is the CPU, and external devices. What are the examples of these peripherals? Examples are the keyboards, mice, printers, sensor, and the storage device. And it also involves both hardware and software mechanism to ensure efficient data transfer between the CPU and the external devices. That's it. This is called the interfacing. So what are the importance of interfacing? First of all is the first point, data transfer, which enables the exchange of data between the computer and the external devices. It facilitates smooth communication and data flow. Second one is the device control, which allows the CPU to control and monitor the operation of peripherals. And also it ensures that device operate as intended and respond to user commands. Next point is system integration. It facilitates the integration of various hardware components into a cohesive system. And it also ensures that different devices can work together seamlessly. Next one is the performance optimization. It ensures efficient utilization of system resources, and it also minimizes delays in data transfer, enhancing overall system performance. Last one is the user interaction. That is, it enables interaction between user and computer system through input and output device. It enhances user experience by allowing intuitive control and feedback. So this is the interfacing in importance. Next one, the next slide. The types are memory interfacing and input-output interfacing. In memory interfacing, it is the connection between the CPU and memory components such as RAM and ROM. What are the key functions? It enables the CPU to read from and write to memory efficiently. That is the RAM and the ROM. It involves address decoding, data buses, control signals, and a lot of this, which manages the timing and control of data transfer. What is the importance of memory interfacing? That is, it ensures that the CPU can access data quickly, which is vital for system performance. Next one is input-output interfacing. This is connects the CPU to external input-output device. From the name, it's already discussed. How to implement this? Number one is programmated input-output, where the CPU directly controls data transfer. And it is simple but can be inefficient as the CPU is busy managing the transfer. Next one is interrupt driven input output, which sends interrupts to the CPU when they need attention. It also allows the CPU to perform other tasks while waiting for input output operation. And the last one is the DMA, that is the direct memory access. That is, the device can transfer data directly from memory without CPU intervention. It increases efficiency by freeing the CPU from managing data transfer. So, what is the importance? It facilitates communication with a variety of devices, enhancing the system functionality. That's all. These are the types of interfacing. Next part is the types of memory interfacing. In the first part is RAM, that is random access memory interfacing. What are the characteristics of this? It is volatile memory used for temporary data storage. Data is lost when power is turned off. And what are the operations? It allows both read and write operation, making it suitable for active data processing. And what are the examples? SRAM, DRAM, that is a static RAM and the dynamic RAM. We all know. Next one is ROM, read-only memory interfacing. In characteristics, it is non-volatile, unlike the RAM, which is volatile. Used for permanent data storage. It retains data even when the power is turned off. In operation, it allows only read operation. Write operations are limited to specific types. And examples of ROM is PROM, EROM, and EEROM. There is programmable ROM, erasable programmable ROM, electrically erasable programmable ROM, and the flash memory. So these are the types. So going to the next slide. The next part is the parallel communication interface. So what is this? A parallel communication interface is a method of transferring multiple bits of data simultaneously over multiple channels between the devices. That is a parallel connection. It is commonly used for high-speed data transfer between a microcontroller and peripherals such as printers, display, and memory devices. What are the importance? It enables faster data transfer rates compared to serial communication, making it suitable for applications requiring high bandwidth. So, what are the working principles of parallel communication interface? First one is multiple data lines. Data is transmitted in parallel using multiple wires, that is 8 bit, 16 bit, 13, 2 bit, transfers 1 bit, 2 bit, and 4 byte at once simultaneously. Next one is the control signal. It allows additional control lines which is used to manage the timing and synchronization of data transfer. Key control signals include read, write, and strobe. Third one is the clock signal. A clock signal may use to synchronize data transmission between devices. It also ensures that both the sender and receiver are aligned in terms of timing, preventing and data corruption. And the last one is a data transfer process. The sender places data on the data lines, the receiver reads the data in parallel, allowing for quick and efficient data transfer. So, this is the working principle of parallel communication interface. Moving to the next slide. This is the examples of parallel communication. We have already learned how a parallel communication works. These are the examples. In first example, microcontroller to LCD display. How it operates? It sends character or command data in parallel to control the display. And what are their application? It used in embedded system for user interface, allowing for real-time updates and interaction. Right? Next one is microcontroller to printer. Same like the LCD display, it transfers print data and control signal to a printer. And its application, it's commonly used in older printers, enabling fast data transfer for printing documents. And the next one is microcontroller to external memory. What are the external memory here? RAM on ROM. So it also reads and writes data to or from RAM on ROM. So up to this it is clear. Now the advantages of parallel communication. There are various advantages. High speed, that is, transfers multiple bits simultaneously, makes it faster than serial communication. Second one is simple implementation, that is easy to interface with devices that support parallel communication requiring straightforward wiring and control logic. Third one is real-time data transfer. It is suitable for applications requiring high-speed data exchange such as video processing or printing, where delays can be detrimental. Last one is wide compatibility. That is, it's commonly used in legacy systems and devices like printers and display. Clear? So these are the advantages. Already we know that parallel communication is very much advantageous than the serial communication. So moving to the next slide. So this the serial communication. How a serial communication works and this what is called serial communication. We all know a serial communication interface is a method of transmitting data one bit at a time over a single communication channel. It is widely used for data exchange between microcontroller, sensor, and peripherals due to its simplicity and efficiency. An importance essential for modern communication system, particularly in embedded system and IoT devices. So how it works, working principle, how it works. Number one is data transmission. Number two is types of serial communication. So what are the types of serial communication? First one is asynchronous communication. Second one is synchronous communication. Clear? In asynchronous communication, we commonly used UART. So what are the significance? Significance are reduced wiring. It requires fewer wires compared to parallel communication. Long distance communication, which is suitable for transmitting data over longer distance. It also consumes low power rather than parallel communication. Scalability is easily adaptable for communication with multiple devices and wide applications. Like examples are embedded system, IoT device, and communication. So up to this, the interfacing part is done. Serial communication and parallel communication, what are they and the significance, all are clear. So thank you.